Data Structures course. Myself Pooja Vyas, and we are going to look at sorting and searching. So today we are going to look at linear search and binary search. So let us see linear search algorithm. Linear search is also known as sequential search, and it is the simplest search algorithm that finds a key element in a list. So we are given a list and we are given a key element. We have to find that key element from the given list. So for that, we will compare that key element with the elements of array one by one. This procedure is known as linear search. So key element is compared with each element of the array one at a time in sequence. So it is a special case of brute force search, and its worst case cost is proportional to the number of elements in the list. So if we want to find a key which is present at the last index in array, then we have to traverse all n nodes. That's why in worst case, it is proportional to the number of elements in the list. So let us now see the example of linear search. Okay, so we have to search for key 10 in given array. We're given this array, and we have to compare key element with element at ith index in array one by one until the key element is found or the array is reached. So in first step, our I will be pointing to 0. So index I will be pointing to 0, and we will compare key element with the 0th element. So key is 10, but I is pointing to 23. So we will move forward, and in next step, I will be incremented by 1, and now we will compare key which is 10. 92 is not a match, that's why we will again move forward. Again, 10 is not equals to 36, so we will move forward. Now we got the element 10 at the index 3. When our I is at index 3, we got the key element 10. So in that case, we will return the key. Okay, so the element 10 is found at ith index, and that index is 3. Let us now see the linear search algorithm. So we are given 3 inputs, that is array A of size n, and we are given integer key that we have to find from the array. What should be the output? The output should be first index of key in A or -1 if that key element is not found. So this is the simplest search algorithm in which we go from index 0 to n-1. Okay, and from that index we compare the key element with the element which is present at ith index in array. So for example, we are given 3 elements in array, and key to be searched is suppose 2. So in that case, first of all, key is compared with the ith element, means key is compared with 1. Match is not found. Match is not found. That's why we will move forward, and now I will be pointing to index 1. This is index 0, right? So now key is matched with this element in array. That's why we will return index I, which is 1 in this case, right? So we will compare element at ith index with key, and if match is found, then we will return the index I, right? Here, -1 means if this condition is not true for any element, then in that case, key element is not present in the list, and we will return -1. Okay, so this was linear search algorithm. So in best case, the best case time complexity will be constant time, that is order of 1. And when will best case occur? If we want to find key 1 in the list 1, 2, 3, then this key is present at the first index. So in that case, only one search will be required. So that will be our best case. Okay. Suppose the key to be found is 3. So in that case, we have to traverse whole list to find that key element if the key element is present at the last index of array, right? So in that case, the worst case time complexity of linear search will be order of n, big O of n. Let us now see binary search. Okay, this is the second searching technique. In linear search, we were using brute force approach, means we were comparing key one by one. But the disadvantage is, if we have larger array, then linear search will be not much efficient. So in that case, we will need some efficient searching technique, and that is binary search. So the precondition of binary search algorithm is the input list should be sorted. So before searching using binary search algorithm, the input array must be sorted. Then and then binary search algorithm can work, right? It follows the divide and conquer strategy, means we will reduce search space to half in every iteration. Okay, so the search space always reduces to half in each and every iteration. Let us now see the example of binary search. So here we are given a key, that is 23, which we have to find from the given array. Okay, so here we can see that given array is in sorted order. If the array is not in sorted order, then first of all the array needs to be sorted. So the procedure in binary search is, first of all, we have to identify low index and high index, that is the first index and the last index. Okay, and then we have to find the middle index. Then we have to compare key element with the element which is present at middle index. If match is found, then middle index will be returned. Otherwise, if key is greater than the element which is present at middle index, then we have to search into right sublist. And if the key is less than the element at middle index, then we have to search at left sublist. So let us proceed with the example to get the clear idea. First of all, we will define these low, high and mid index, right? So in this array, let us write the index number. This is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so in this case, our first low index would be 0 and high index would be 9. How we can find middle index? Middle index will be low plus high divided by 2, and we will take floor value of that. So it will be 4. Means at fourth index we have found our first middle element, right? Now we will compare cases. There are 3 cases. First is if key is matched with the middle element. Second case is if key is greater than the middle element, and if key is less than the middle element. Okay, so let us compare key. What is our key? Our key is 23. Okay, and the middle index that we got is 4. So element at fourth index is 16, right? So this is what? 16. So 23 is greater than the middle element. That's why now we will divide our search space to right sublist. So now we will search the given key in right sub array. Okay, so now we will search this key in right sub array and update. Now we will update search space. Means now as key is greater than the middle element, means we have to search right sub array. Now what will be the right sub array? If this was middle element and if the key which is 23, okay, so 23 is greater than 16. So we will search this list now, that is right sub array. Okay, so in that case high index will be pointing to 9 only, but we have to update the low index. Here low index was pointing to 0, but now we have to search the elements in right sub array. So in that case we have to update our low index over here, right? So now low will be pointing at 5. So how do we get this index 5? So low will be what? Mid plus 1. So middle index we found was 4 and 4 plus 1 was 5. So our low index is 5 and high will be pointing to 9 only. Okay, so in next iteration our low will become 5 and our high will become 9. So 5 plus 9 divided by 2, that is 14 divided by 2 means 7. Okay, so the middle element we found in the right sublist will be 56, right? So this is our middle element. Fine. So we will compare key which is 23 with the middle element which is 56. Now 23 is less than 56. Okay, so in that case now we have to search left sub array, right? Now we will search left sub array. So in that case our left sub array would have 2 elements, 23 and 38. This will be our new list at left. In that case low will be pointing to the same index which is 5, but now high will be pointing to what? High will be pointing to 6. So how we got 6? So in that case if we want to search in left sub array, then we have to update high index which is mid minus 1. Okay, and middle index we got is 7. So 7 minus 1 will be 6, right? And low will be pointing to 5 only, as low is pointing to 5 in this iteration. Okay, so low will be as it is, but we have to update high. So means if we are searching right sub array, then in that case we have to update low index, and if are searching in left sub array, then in that case we have to update high index, right? So now our new index will be 5 and 6. Again, we will take 5 plus 6 divided by 2 and its floor value. So, which will be 5. 11 by 2 and it will be 5. So, at index 5, which element we got? At index 5, we have 23. Okay. So, our key to be searched is 23 and at index 5, we got 23. So, now the match is found. Okay. So, if match is found, what will be returned? We will return index mid. Okay, and here in this iteration, mid index we got is 5. Okay, so return mid and mid is 5, right? So what should be the output? Output should be 23 is present at index 5. Okay, so this is how we can reduce search space by half in each and every iteration. Means there are 3 cases. First case is if key is equals to element at the middle index. Okay, then simply we will return what? Middle index. What would be the second case? It would be if key is less than the middle element, then in that case, we have to search in left sub-array. Okay, as the list is sorted, and obviously if key element is less than middle element, then we have to find left sublist. And if you are searching in left sublist, low index will remain same, but high index will change. Okay, so how high index will be changed? It will become middle index minus 1, right? So if you are searching in left sub array, then your high index will change. If key is greater than the middle element, then in that case we have to find key in right sub array. Okay, and if we are searching key in right sub array, then high index will remain same, but only low index will change, and it will be changed to what? Mid plus 1. Okay, so this is the algorithm of binary search, in which we have to compare key according to these 3 cases, right? Let us now see the one more example of binary search. In this, so here we are given key 37, which is to be found in this array, right? So as we can see, the array is unsorted. So first of all, we have to sort the array, right? And then we have to start applying binary search on this array. Okay, so in first step, we will sort the array, and array will look something like this. 1, 4, 7, 11, 15, 22, 37 and 40, right? So we have total 8 elements and our index will start from 0, 1, 2, 3, 4, 5, 6 and 7. So total 8 elements are there, and first thing we will do is find middle index. Okay, so our low index is 0 and high index is 7. So 0 plus 7 by 2 will be 3.5. An integer of 3.5 means floor value will be 3. So at index 3, we have found our middle element, right? Now, the next step is to compare this middle element with key, and key is 37. So, we will compare 37 with 11. 37 is greater than 11. So, in that case, we have to search in this right sub-array, right? And if we are searching in right sub-array, we have to change the low index, and now low index will be pointing to index 4. This will be our low index, and that we will get by adding 1 in the middle index. Middle plus 1 will be new low index, right? So in second step, we have divided our whole search space to half, and now we will search the key element in this just 4 elements, right? So now our low index is pointing to index 4 and high index is pointing to index 7. So 4 plus 7 by 2 will be what? 5. Okay, that means the next middle element we found is 22, and we will compare the key with 22. So the key is greater than 22. So in that case, we have to find key to the right list from the right list. Okay, so key must be present at right. Getting? So if we have to search in right sublist, then low index will be updated, and that will be middle plus 1, right? So low will be pointing to what? 6, because middle is pointing to 5, right? So now we will update low index to 6, right? So now we are searching key element in this array. So first step is to find middle index, right? So low is pointing to 6, high is pointing to 7. 6 plus 7 by 2 is 6, means our middle element is present at index 6. And as we can see, our key element is 37, and now the middle element is also pointing to 37. So we have found the match, and middle index will be what? 6. So in that case, we will return middle index. So the output should look like 37 is present at index 6. So let us now see binary search algorithm. As we have seen in example, we will need a sorted array as input of size n and a key to be searched. In output, we will get the first index of the key which is present in array A. Right? So binary search, we will start with initializing low and high index. Low would be pointing to first element and which is present at index 0. And high will be pointing to the last element of the list which will be pointing to n minus 1. Okay? Till the low index remains less than or equals to high, we will keep dividing the search space by half. Right? So first of all, we have to find the middle index, which is low plus high by 2. Then we would be comparing three cases. If key is equal to the middle element, if key is less than the middle element, and if key is greater than the middle element. If key is equals to the middle element, then we will simply return middle index. If key would be less than the middle element, then we would be searching in the left sublist. And if we are searching in left sublist, low will be pointing to the same index, but high should be updated as mid minus 1. Okay, and the last case is if our key is greater than the middle element, then we have to search in right subarray, and in that case we have to change the low index, and that would be middle plus 1. Okay, so this was the algorithm for binary search.